Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science Engineering in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about graph introduction. So, very first thing is that the graph is nothing but a collection of points in the plane called as vertices or nodes. So, which that one should be connected by means of a line segment called as edges or arcs. Okay, so the graph is not nothing but a collection of points in the plane. So, which one called as a nodes or edges, sorry, nodes or vertex, and which is going to be connected by means of a line segment, so what we called as an edge, or been able to call it as an arc. And the graph can be represented as g of v comma e. So v is nothing but set of vertices and e is nothing but set of edges here. So what should be the category of a graph? So there are different types of graphs. So what we call it as directed graph or undirected graph. So the other synonym what we call it as directed graph is digraph here, and undirected graph, so this should be another kind of the graph here. So in undirected graphs, so a pair of unordered vertices such that uv and vu should be same here. So in the undirected graph, the edge may not have any kind of directions here. So that's why this one called as undirected graph. Edge what can able to write UV, I can also able to write as VU. So this should be the same in case of undirected graph. So when it comes to the directed graph, so the edge is going to be represented with an arrow. So and but in this case, the edge UV may not equal to VU here. So because we have go from one, the arrow is going from one direction only. Suppose if I'm going to have another direction like this, then I can able to write UV should also be equal to VU. So these are the cases in case of a directed and undirected graph here. So the graph which is going to maintain and directed edge, so that should be called as a directed graph. A graph which is going to maintain an undirected edge, so that one should be called as undirected graph. So graph representation. So there are two ways of representing a graph data structure. So first one is adjacency matrix and second one is adjacency list. So the graph representation. So here the graph can be represented in two forms. So very first one is that adjacency matrix. So these are the set of vertices in the graph. So in this one, so I'm going to consider a matrix which is able to contain these rows and columns. So if there is an edge present from A to B, so then I can able to write it as 1. So remaining I can able to call it as 0 here. Then B to A, B to C, B to D, remaining 0. Similarly from C to A, C to B, C to C 0, and from D to B and C. So like this we are going to represent an adjacency matrix here. Similarly, adjacency list means, so here I'm going to consider nodes. So in this one, if there is an edge, so I can able to represent with the form of a linked list representation. So what are the edges that are connected to A is B and C, so remaining this one should be 0. Similarly for A, it should be B to A edge is there, and from B to C, and from B to D. So like this, we are going to represent the adjacency list representations of the graph. So let's consider an example like this. So adjacency matrix is a two-dimensional matrix with n number of rows and columns, so which is going to be assigned either 0 and 1. So if I'm going to assign A as equal to, means that if there is an edge vertex, A and J are to be connected. So suppose if this is the given graph, so in this given graph, if I'm going to consider edge, so there is no edge from A to A, so that's why I'm going to call it as self loop here, so that this one is not there, that's why I'm going to write it as 0. And similarly, there is no edge from A to D, so that's why I'm going to write 0 here. And similarly from B to B, so there is no edge from B to B, and then B to C also no edge, so that's why I'm going to mark it as 0 in this case also. And from C, if I'm going to consider, then C to C there is no edge, and C to B there is no edge, so that's why I'm going to write it as 0 and 0 in these cases. And from D to D and D to A there is no edge, and D to D there is also no edge, so that's why, so I am marking it as 0 here. So like this, we are going to represent this graph adjacency matrix representations using graph here. So adjacency matrix is nothing but a two-dimensional matrix of size n by n. So the size is 4 by 4. So which means that if there is an edge from A to B, then I can able to write it as 1. Otherwise, I can able to mark it as 0 if there is no edge. An adjacency list is the graph or diagram that should be collection of linked list, and all its adjacency vertices are going to be connected by an edge. Suppose in this case, so these are the set of vertices. So what are the edges that are connected to A? So B and then C. That's one I can able to write it here, the form of linked list. And similarly, I can also write like this. Similarly, the edges what are going to be connected. So that one also I can able to mark it as like this. And from C to, and what are the vertex that is connected, and similarly what are the vertex that is connected. So weighted graph is nothing but a graph, so with a number assigned to the edges, and these numbers are called weights and then costs. So example, weighted adjacency matrix. So weighted graph is the graph, so with the numbers that is going to be assigned the edges, and these are called as weights and costs. An example, weighted adjacency matrix. So that means a edge which is going to be carry and weights along the edges. This thing will be called as a weighted graph, and these weights are going to be mapped in the weighted adjacency matrix. Suppose, so what is the edge that is from A to B? So the weight is 1, and similarly the edge from A to C 2, and from A to D that should be 5. Similarly, B to A, sorry, if I'm going to take edge from B to A, the weight is 1, and similarly B to D that should be 1. Similarly, so C to A is 2, and C to D is 3. So like this, I can able to represent it what we call it as a weighted adjacency matrix. So if I'm going to represent a weight here, then I can able to represent as a weighted adjacency matrix. So the weighted graph is nothing but in this graph the edges are going to carry the weights, and these weights are going to be presented in adjacency matrix. And weighted adjacency list means so it includes the vertices names and weight, And so in this one, so along with the nodes, I'm going to represent the weight value also here. So in this weighted adjacency list, I can able to represent the nodes along with the weights also. So when it comes to graph technology, so we are going to see some of the basic terms like node. So node is nothing but a collection of point called as a vertex here, or I can able to call it as a node. And edge is nothing but a line segment that is connected to the vertices. And adjacent node means that which is going to connect the near vertices. And degrees of node mean the number of edges that are connecting to that node. So the degree of A equal to 2. So why? Because there are two edges are connected with this vertex. So that's why the degree should be 2 here. Similarly, for what is the degree for B? That should be 1. So one node is connected. So here also one edge is connected. That's why. So the degree of B and C should be 1. So node is nothing but a collection of points called as a vertex, and the line segment what we call as an edge, and the nodes which are connected near to vertex. Suppose so A is adjacent to C as well as A is adjacent to B, and C is also adjacent to A, and B is also adjacent to A. So these are the adjacent vertices. And degree of the node means the number of edges that are connecting to this vertex should be treated as a degree of that node. So in case of undirected graph, so I'm going to see this in degree and then out degree. So these two basic terms should be considered in case of directed graph. So in degree means if a vertex is there, so the number of edges that are incident to the vertex should be treated as in degree, and the number of edges that are leaving from this vertex should be treated as out degree here. Now next one is that size of the graph. So size of the graph is nothing but the total number of edges in the graph. So that should be treated as uh, size of the graph. So here, so how many number of edges are there? So 1. So this 2. So the total number of edges in the graph is nothing but the size of the graph. The next one is nothing but path. So path is nothing but a sequence of vertices from starting node to the ending node. So that is nothing but the path here. Suppose what is the path from reach from A to B? So this is the path. What is the path to reach from A to B, A to C, A to B, A to B, and then A to C? So what is the path to reach from A to D? So A to B, B to C, and D to C to D. So here this one what we called as source, and this one what we called as destination. So the path from A to B is only one path, and there exists two paths here. That means A to B, B to C, and B to C. A to B, B to C, and then C to D. So these are now what we call as paths in the graph. And path length, so that is nothing but so the total weight of this distance value obtained by the particular path mm, from starting node to ending node, that should be treated as a path length here. So the total weight distance obtained by the particular path from starting to ending. So what is the path length from A to B? So what we call it as a distance. So that should be 1. A to B, B to D, how much? So 1 plus 2, 3. A to C should be 3. And or otherwise I can able to write as A to B, B to D, and D to C also I can able to move. So 1 plus 2 plus 4, that should be 7. So like this, we can able to estimate the path length. So by calculating the sum of all the weight values. So connected graph means that every vertex are going to be connected, and not connected graph means that every vertices are not connected. So that should be not connected graph. So example, so this should be the connected graph, and if there is a graph like this, A, B, D, and D, E, F. So these are the two graphs, but it is not connected. So that's why it should be not connected graph. And next one, cycle. So cycle is nothing but the path of the source to the ends at the same vertex and does not traverse the same edge more than once. Okay. So cycle is nothing but the path of the source to the ends at the same vertex and does not traverse the same edge more than once. Suppose if I'm going to reach from A to A, so A to B, B to C, and then C to A. So the source and destination uh, should be same here. So a graph which contains this cycle called as a cyclic graph. And similarly, a graph which does not contain a cycle, then it should be called as a acyclic graph. Right. Uh, so here what I'm going to say that is a graph. Suppose I'm going to consider another cycle. So A, B, C, D, E. So what is the source from A to A? So source is A. You can able to go for A to B, B to C, C to A. Otherwise, A to B, B to E, E to D, C to A. So there is a path from source and destination. So it should be the same in the both the cases. So that's why this graph can be called as a cyclic graph. So this is the cycle, and this is also the cycle that exists. So similarly, what is the path from A to E? So I can able to move from A to B, B to E. Similarly, I can able to go from A to C, C to D, and D to E. So like this, I can able to go for different types of paths in the cycle. So that should be about the graph basics here. So in this one, I discussed what is the graph. So graph is nothing but a collection of points in the plane, what we called as a vertices or nodes, and which is going to be connected by means of a line segment called edges and arcs. And so there are different types of graphs like directed graph and undirected graph. So digraph is nothing but the pair of ordered vertices, and undirected graph means pair of unordered vertices. So the graphs can be represented in two ways. So what I said is that adjacency matrix and adjacency list. So adjacency matrix means it should be a two-dimensional matrix. So that is going to be filled with either zeros and ones. So if there is exists a zero, or if there is exists an edge between the two vertices, I will be marked as one, otherwise should be marked as zero. And similarly, adjacency list means I can able to represent the form of linked list. So what are the edges, what are the vertices that are connected to each vertex, so that should be represented. And weighted graph means that, so here the edges is going to carry some weights, and there the matrix what I'm represented through weights what we called as a weighted adjacency matrix and weighted adjacency list. So in the node along with the vertices, we have to represent the weight as well. And when it comes to graph terminology, so the node, the basic terms in the graph will be node. So the node is nothing but a point, what we call as a vertex, and the line what is connecting between the two nodes should be called as an edge. And adjacency node means which is going to connect the two vertices, and degree of the node with the number of edges that are connected to that node. And the size of the graph means that the total number of edges in the graph should be treated as the size of the graph. And the path is nothing but a sequence of vertices from the starting node to the ending node. So what is the path length? So path length is nothing but the total weight value of the that is going to be obtained by a particular paths starting node to the ending node. So the graph is going to be connected if there exists an edge for every pair of vertices in the graph. Suppose if I'm going to draw a graph, so this is not a connected graph. And if I'm going to draw this one, so for every uh, the edge is going to be the vertex is going to be connected to all other remaining vertices, then it should be a connected graph. So in this one, it should be a not connected graph, because if I'm going to draw this one also, then it should be a connected graph. Now cycle. So cycle is nothing but if the source and destination is the same, then I can able to call it as a cycle. And the graph which contains the cycle called as a cyclic graph, and the graph which does not contain a cycle then should be called as a acyclic graph. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.